we are going to discuss a very important topics called as periodic properties, okay, of a modern periodic table. So what do you mean by periodic properties? The properties which repeat itself after a fixed time interval are called as periodic properties. If you, for example, if you say starting of first period in your school, suppose if it starts at 9 o'clock daily, so it repeats after 24 hours, right? So that is a periodic function, right? Rising of sun daily, at what time? Generally, if you take 6 a.m., right? That is also a periodic function. Why? Because it is a repeating itself after a fixed time interval, right? So here in our syllabus, what are the periodic properties we have to study? Periodic properties are, first one is atomic size. Second one is ionization potential. Third one is metallic character. Fourth one is non-metallic character. Fifth one is electronegativity. And sixth one is electron affinity. So these are the six main periodic properties which we have to study in syllabus. Atomic size, also called as what? Ionic size. Ionic size or atomic size will have the same kind of properties variation. Okay, ionization potential, metallic character, non-metallic character. Now first we will discuss about the atomic size. See, what do you mean by atomic size? You know how atom is? Atom contains nucleus at the center, yes or no? And electrons are revolving around the nucleus in circular path. This path is called as what? Orbit, okay, or also called as shell. So an atom may have one shell, two shell, three shell, four shell. So suppose if an atom has two cells, so distance from the center of nucleus to the outermost cell, this distance is called as what? Atomic radius. It is called as what? Atomic radius. Okay, so atomic radius is defined as the distance from center of the atom to the outermost orbit. Okay, now next they will ask you how it varies along the period and across the group, okay, or across the group along the period. If you see along the period, okay, or across the period. So if you take the examples like boron, carbon, nitrogen, oxygen and fluorine. What is the atomic number? Boron 5, 6, 7, 8, 9. So generally atomic number is nothing but number of protons which is present inside the nucleus of the atom. So number of protons is here 5, 6, 7, 8 and 9. So here if you do the electronic configuration, so here we can find 2, 3, right? Here 2, 4, here 2, 5. In this oxygen 2, 6, fluorine 2, 7. Now if you see, the number of cells are equal in each of the elements, whether it is boron, carbon, nitrogen, oxygen or fluorine. Only difference is what? The number of electrons present in the last cell, okay, it is increased. What is actually happening? As the number of protons is increased by 1 and as we move from left to right, so where is proton present? Proton is generally present inside the nucleus of the atom. So it leads to the nuclear charge. Nuclear charge is due to the number of protons. If the nuclear charge is more, so nucleus will attract the electron, okay, with a more force. If the nuclear charge is less, nucleus will attract the electron with a less force, right? Here if you see, here 5 protons is trying to attract these 3 electrons. Here what is happening? Here 6 proton is trying to attract the 4 valence electron, right? Here 7 proton is trying to attract the 5 valence electron. So as we move from left to right, nuclear charge increases. Okay, so if you see, take this example, suppose this is the nucleus, this is the outermost shell electron. Okay, it is here. 5 proton attracting this electron, so it is here, right? Now suppose 6 proton comes, so force of attraction will increase, it will come closer to nucleus, right? Suppose it becomes 7, so it will again come more closer to it, right? So in this way, what happens if you move in a period, okay, so the atomic size decreases. Atomic size decreases from left to right. Getting? Next, what happens in a group? You will see. You take the example of group 1. Okay, group 1 you take hydrogen, lithium, sodium, potassium, rubidium. Okay, what is the atomic number of hydrogen? 1. Lithium 3, 11, 19, right? If you do the electronic configuration K, L, M, here 1 only, here 2, 1, 2, 8 and 1, 2, 8, 8, 1. Yes or no? So what we see here is hydrogen, only one shell is there. Okay, lithium, there are 2 shells are there, right? When we talk about the sodium, there are 3 cells, 1, K, L, M is there. When we talk about potassium, K, L, M, N, right? So you can very clearly see as we move from top to bottom in a group. So number of cells is increased, right? So this is R1, R2, R3, R4. So R1 is less than R2, less than R3, less than R4. So what is happening? Atomic size, okay, atomic size increases. Yes or no? From top to bottom, from top to bottom in a group. How? Due to increase in number of cells. Due to increase in number of cells. Correct?